Hi guys, welcome back to AI with MJ. As you all know, I'm doing the NeetCode 250 problems, and today I'm gonna be doing problem number 8 from that list. So let's get started. As usual, the goal is to finish it in 25 minutes, along with a few variants. I'm gonna be pasting the question and starting the timer as well. Alright, so the question is, given the array of size n, return the majority element. The majority element is the element that appears more than n by 2 times. You may assume that the majority element always exists in the array. So for example, in this one, if the numbers are 3, 2, 3, then the output would be 3. And in example number 2, so if there is numbers like these, the output is 2, because there is 4 occurrences and here there are 3, and there were like 7 elements in the array. Okay, a few questions I would ask would be like, is it just positive integers? Wow, positive integers. Second would be like the size of the array, and also if there are any like memory constraints, and like how big the numbers could be, like length of the number. Okay, so for this time we are assuming it's only positive integers, and then the size of the array could be like 5 into 10 to the power of 4, and yeah, that would be it. Length of number would be like n would be equal to the number length. Okay, first thing that comes to mind is like we can just count all the elements and store it in a dictionary, let's say, and then just go over this dictionary, go over the hash map and find the solution and find the max element, or element that is greater than k n over 2. So that is one thing we could do. In this one, the time complexity is O of n for like counting, and then O of n would be to go over the hash map. There exists a solution that is better, and then a follow-up optimization task is do it in space complexity of O of 1. So to do this in space complexity of O of 1, there is a very famous algorithm called Boyer-Morse algorithm. And what this says is that for example, if this is your input, just assume like the first element that you are at, which is 2, is your answer. So your result is your answer, and then just count how many times has it appeared. So right now it's 1. Then when you move forward, add it to 2 again. Now when you see 1, this is not the same as the result that you expected, right? So decrease the count by 1. So right now it's this, and then again come forward, and since they are not like it's still like 2 is the majority element for now, so we're gonna like decrease the count by 0, and then here we come back and make the result to be this 1 again, because it was in the majority element, and then we also increase the count by 1. Now when we move forward, we're gonna see that 1 occurs 2 times, right? And then the count is through. But now when we added this 2, this count becomes 1, and then we come here and then the count becomes 0 for 1. And since the count was 0, the result would be 2, because that's what we are planning to like achieve, the majority element, because at 1, when it was the last element, the count became 0. And this solution works because it's like you're doing the alternate one, and even if you add like however way that you do permutation and combination and like put it here, it will always result in like finding the max element. And this solution usually works when you only have to find like n by 2 like elements, like majority element when it's n by 2. So just to get started, let's call this the class of solution with more, right? And then we can do define find majority. And in this one also, we could have just confirmed in the question itself that like input, it's a list, right? I think that's what they mentioned, so never mind. So nums, and it will be a list of integers from typing import list and default dict, and our output is an integer, so there is that. As we don't need the default dict, actually this was for the earlier solution that I was mentioning. And why this more solutions also works is because we do not keep anything in memory except the 2 variables, and and little time would be O of n because we are only going over the array once. So when we come here, as mentioned, we'll have a result variable and a count variable, both set at 0, and then we do for number in nums. So if so here, if the number is equal to the result, that is we're good, then we increase the count plus equals 1. Otherwise we decrease it by 1, right? Like for example, when it was 2 we were increasing, and then when it came to 1, then we decrease the count. So exactly that. And if suppose like if count is equal to 0, then we do result is equal to the current number, and at the end we just return the result. Let me do a quick dry run. So let's say this is our numbers, and here our result is 2, our count is equal to 0. I mean, we start with 0 0 and we were here. So when we come here, we see that if count is 0, then this result is equal to number, so this result becomes 2 and the count becomes 1. And then if number is equal to result, which is the case, that's why the count increased, then we move forward, then we come at 2 and we see this is not true, we come at this condition, count becomes 2. Then we come here at 1 and then we see that that's not the case, and this else condition executes, so this becomes 1. Then we come here at 1 and we see that again this condition will execute, so 0. Now when we are at this number, we see the count is 0, so what we're gonna do is we're gonna take the result and make it 1, because this line will get executed. And then when we move from count, and the count becomes 1 because number is equal to result. Okay, then we come at 2 and then we see that they are not different, like this part will execute because the result is not the same as the number. So this becomes 0 again, and then we move to the last number, and here we check that 0 is the count, so we are gonna replace this with 2, and this becomes 1, and then we just return the result because we are at the end of the numbers list. That's how it works. So yeah, here the time complexity as mentioned is O of n, and space is also O of 1. This is one other variant that I found. So this is pretty much like the same question, but like all the elements are non-negative and the same elements are adjacent in the array. Find the majority element, and here the majority is not like n by 2, it's n by k, and in the input they also give k. So this is the example for that question. So in this there are 2, 4, 6, 8, 10, 12. So n is equal to 12 and k is equal to 3. So n by k is like 4 here. So we have to find an element that is bigger than 4. So we do 0. So again, the same HashMap solution works just fine, but obviously that would not give the best results because of additional space required. And for this solution we can just do like more solution, but like we can make it more general. And why this more solution would not work is because this is n by k, and there could be like we need to track more numbers, and in most we only track one number. So usually, like if you look at the math of it, so this is how it works out. So if it's n by 2, we just need to like track one candidate, like one result. But then if it's n by 3, we need to track like 2 results, and then we know that if it's n by k, then we need to do like k minus 1 results, like tracking. So for in this case, this is like 4, right? So we need to track 3 candidates, 3 results. And why this works is because we know that at any point there could not be any majority element that would exceed this condition. There could only be like 3 possibilities, so that's why we need to track that. And then how this solution looks like is, actually I'm not like just gonna code it up. What I'll do is like just go over an example and do the dry run. So give me 1 second, let me just paste the example. Okay, so in this one, let's say our number is this, right, and k is equal to 3, and we need to, it's the same example, sorry, my bad. And how this algorithm will work is at step number 1, when the number is 1 here, then we will just add it to the candidate. So let's say this is our result, and we'll add 1 because 1 occurs 1 times. Then we move to step 2, and this occurs same, so 2, and this continues until we are here, which is at index 4. And then when we come at 3, we see that that's not the case, and we can have like 3 states, right? Because sorry, in this one we can only have 2 results, so because it's k minus 1, so 2 results can be stored, can be tracked basically. and we see that at this 3 this thing changed, so we will add that 3 occur once, but we also need to decrease this count because this Morse algorithm would, like, it's like when one person comes and they don't match during the voting algorithm. Like if someone is voting and like a new person comes and they give a different opinion, their opinion could be like heard, and then if it is not the majority, then you can just reduce one voice to equal it out. So that is what is happening in this algorithm. So this becomes 1 3 and 3 1. Actually, I'm not sure if we need to decrease this count, so let's keep it 1 is to 4. By now 3 is to 1. Then when we come here at 0, actually we come at 4, and that's when we see that like all the like maximum are in the state. And then since this is the minority, like, so we'll delete this 3, so this 3 gets deleted, and then we move on, and then we come to 0. Yeah, we come to 0, and then we also decrement 1 from here, and then we add this 0 in there and make it 1, and this keeps on going until 3 4 5. So 0 becomes 5, so that keeps going. And then when we are at 9, we see that okay, at 9 we need to decrease it because all of these states are full, so this becomes 2 and this will become 4. Now we need to verify, like there could be a chance that like no majority element occurs. So when we go there, here, yeah, so we'll verify in this candidate state, in the result state basically, that okay, right now there is 1 that occurs 2 times and 0 that occurs 4 times. And then we'll just check that like okay, the count is 4 for 0, so that could not be the answer, and let's just move on and return 0. So there is an additional verification step. We recount only for like these results, and yeah, that would be it. And I think I might not have been able to explain this exact thing properly, but like if you write it down, you should be able to do it. It's not that hard. But if you do have any comments, or if you think I did not explain something well, please feel free to comment, and keep learning, and thanks for watching.